All right, say hi to everybody, the folks at home. Say hi to all the folks at home. That was not really a rousing greeting to the folks at home, but it'll do. Nicole Blowers, class of 2011, thinks that no one watches these things. Just so we're all clear on that, if you want to send her a Facebook friend request for the sole purpose of saying, I watch these videos, you may do that. Blowers rhymes with flowers. So, I got to do a quick teach piece on this show about implicit differentiation. We're going to put the implicit back in implicit differentiation. We remember that the deal with implicit differentiation was that you had these functions, well, they weren't functions, but you had these equations where you couldn't get y by itself. And so we quit. That's great, because what do we do whenever anything in life gets hard? We quit. Glorious. Glorious. This is the most glorious day of my life. So here's the thing. I want to do a couple of things with this. I want to find the equation of the tangent line at what point? Oh, lesson plan. At what point? 1, -4. You can see for yourself that 1, -4 is on the curve. You can do that either by graphing it, which I don't advise, or by substituting 1, -4, which I do. 1, -4 is on the curve. Want to do that, and then I want to find horizontal tangents if there are any. We'll call them hortans for short, and we'll find vertans for short on the other side. We'll find vertical tangents. That's the spirit. So here's the thing. Remind me, oh, people who want to pass on May 4, remind me how we find an equation of a tangent line. Yeah, because it's y minus y1 equals x minus x1 multiplied by the slope. And that's where so give me something and tell me where to stick it. Right, minus -4, that's good. X minus 1, that's good. And so all we need is a slope. Where's the slope going to come from? It's going to nowhere. It's going to the slope fairy will bring it like the stork brings babies. How do you do it? There we go. I'll do the right side. It's the least I can do. I'll do the right side. The derivative of 12 is 0. And so the least you can do is the left side. The product rule is so much fun. It's 1 prime 2 plus 2 prime 1. Oh, calculus, oh, calculus. That equals 0 has to move, 'cause we'll never fit the other part. Plus, got it? Plus, second times derivative of first. The product rule is so much fun. It's 1 prime 2 plus 2 prime 1. So we might as well get dy dx by itself. How are we going to get dy dx by itself? Suck it out. That's great. I'm more of a suck it in kind of a guy, but we'll suck it out. We got to kick those puppies over to the other side. We got to kick the 2xy out and the y squared out. And then we'll divide by everybody that had a dy dx in the first place. What's that? X squared plus 2xy? I can't stick that in a slope spot. What do you stick in the slope spot? Where'd it come from? You're okay? You're okay. Are you okay, folks at home? We can't stop for you, so we'll just go on. What happens? If you have any questions, folks at home, just call us now and we'll stop what we're doing in the past for you. That would be super. Let's just go back in the space-time continuum. You substitute 1, -4, so you substitute 1, -4, that's, let's see, -2 times that's 8, minus a 16, that's -8, and then who's on bottom? Don't even go there, that's what, -7? -7, let's do that. So what do you got? 8/7. There it is. That'd be an awesome, like, 3-point question. 3, maybe 4. It'd be even better if it weren't a question, but then it wouldn't be a calculus test, would it? Horizontal tangents. What's the deal with a horizontal tangent? Derivative equals 0. We'll change color. The derivative equals 0. If the derivative equals 0, well, only the numerator matters, n'est pas? So the numerator on that fraction is negative 2xy minus y squared. We want that to equal 0. So I'm a big fan of suck. Careful if you got gum in your mouth. You don't want to do that if you've got gum in your mouth. So what does that turn into for us? Did I totally screw that up? No, I didn't. Okay. So I'm okay, right? Right. So either y equals 0 or negative 2x minus y equals 0. So go all the way back up here. Tell me all the points on the curve where y is 0. Go ahead, try. If you substitute y equals 0 back into there, what happens? Nothing. So this yields no solutions. None. Just because you got y equals 0 doesn't mean that you can get y equals 0. You want me to leave the arrow pointing to the equation? I'm going to have another arrow pointing to the equation. Is that okay? And it runs right through blue land. Is that okay? That's okay. So in this case, we've got that y is negative 2x. Time for a little algebra. Oh boy, oh, we lost it. Okay, come back, come back. It'd be nice if I could pinch the screen. If y is negative 2x, then I've got x squared times negative 2x plus x times negative 2x squared is 12. How do you solve that? Yes, Commissioner? I do. What do you need? Got it. Bye. 40, you're going to miss rounds at the end of the period. How do you solve that thing? What? Negative 2x cubed plus... If you want to see if students get things wrong, just give them laws of exponents. You square first, that darn Aunt Sally. So you got 2x cubed equals 12, x cubed equals 6. Give me an x. Cube root of 6. That's not the equation of a horizontal line, but that tells us where the horizontal line will be. To figure out where the horizontal line is, you need the y value that's there. What's the y value when x is cube root of 6? There it is. Negative 2 cube root of 6. So far, so good. And you thought it'd be an easy question, you silly heads. There we go. Well, you could, because you know the relationship between x and y. And since you know the relationship between x and y, we can just sub right in. Well, if that wasn't enough fun, let's go after vertical tangents. To go after vertical tangents, you need dy dx undefined. So x squared plus 2xy equals 0. Bottom equals 0, Mike. That's right. That's right. So here we go. Everybody suck. So I got either x equals 0 or x is negative 2y. Guess which one doesn't yield a solution? X equals 0. There! Thank you, Dora the Explorer. X equals 0 does not yield a solution. But x equals negative 2y does yield a solution. We just have to substitute back into there. So let's see. X squared y plus x y squared is 12. Dare we tempt fate again? We dare tempt fate again, all you crazy folks at home. Negative 2y cubed is 12. So y is going to turn out to be the cube root of 6. What's the x that comes from that? Negative 2 cube root of 6. Which almost makes sense because the very equation itself gives you the idea that you've probably got some symmetry happening with your x's and your y's. It's just a thought. It's a crazy thought. So that is the kinds of questions they will throw at you on implicit differentiation. They're going to ask you how to find a tangent line, and then they're going to talk about horizontal and vertical tangents. That's the kind of stuff we can expect you to do. What questions have you for me? What questions do you have for the folks at home? What's it like in the future, folks at home? That's great. Okay, so there you have it. Tomorrow's short quiz on implicit differentiation, and I think tomorrow's teach piece is on, oh yay, differential equations, slope field, stuff like that. We'll see you tomorrow.